Welcome to day 6 of our high level design course. Today we will be diving into diagrams in HLD, specifically focusing on UML diagrams. These visual representations are crucial in software design, and we will explore how they help in building a strong architectural foundation. Let's get started. UML or Unified Modeling Language is a standardized modeling language used to visualize, specify, construct, and document software systems. It serves as a bridge between technical teams and stakeholders, providing a common ground for communicating complex system designs. UML helps document both static and dynamic aspects of a system, ensuring that the design process is understood by everyone involved. Why is UML so essential in software design? Well, it enables teams to communicate effectively about the system structure and behavior. UML helps in defining the system's architecture clearly, supporting different stages of the software development lifecycle, particularly high-level and low-level design. It makes it easier for stakeholders to understand how the system works, ensuring everyone is on the same page. UML diagrams can be broadly classified into two categories: structural diagrams and behavioral diagrams. Structural diagrams focus on the static structure of the system, such as class diagrams and component diagrams. Behavioral diagrams, on the other hand, represent the dynamic interaction and processes like sequence diagrams and activity diagrams. Both types are essential in HLD, helping to convey different aspects of the system. Let's start with the class diagram. This is one of the most commonly used UML diagrams in high-level design. It represents the static structure of the system by showing classes, attributes, methods, and relationships. The purpose of the class diagram is to define how different entities in the system are related. For example, we might have classes such as user, product, and order in an e-commerce system with relationships showing how these entities interact. Here's an example of a class diagram for an e-commerce system. We have several classes: user, order, product, and payment. The user class might have attributes like name and email, while the order class would include attributes like order ID and order date. Relationships between these classes show that a user can place an order can contain multiple products, and payment is processed for each order. Next, let's look at the sequence diagram. A sequence diagram shows how objects interact in a particular sequence of events over time. It's perfect for showing the flow of messages between objects. For example, in an online payment process, a user sends a payment request to the payment gateway, which then communicates with the bank to process the payment and confirm the transaction. In this sequence diagram example, we see how the user, payment gateway, bank, and transaction interact during a payment process. First, the user initiates a payment, which is processed by the payment gateway. The bank confirms the transaction, and the transaction object updates the order status. Each step is shown in sequence, allowing us to visualize the entire flow of operations. Moving on to the component diagrams, these diagrams are used to represent the major components of a system and their relationships. They show how different parts of the system depend on each other. For example, in a microservices architecture, components like user service, payment service, and inventory service might communicate with each other, each with its own responsibility and set of interfaces. In this component diagram example, we see the interaction between different services in a microservices architecture. The user service, payment service, inventory service, and notification service components each perform specific tasks, and we see how they depend on each other through interfaces and dependencies. This type of diagram helps us understand how the overall system is structured. Creating UML diagrams for high-level design involves a few key steps. First, gather requirements from stakeholders to understand the business logic. Next, identify the major components of the system. Once we know what we need to model, choose the appropriate UML diagram for each aspect. Then map out the relationships between components and refine your diagrams to ensure clarity and precision. Now, let's put this into practice. Imagine we need to design UML diagrams for a library management system. We start by creating a class diagram to represent entities like book, member, loan, and staff. Next, we create a sequence diagram to show the process when a member borrows a book. Finally, we create a component diagram to show the major system components such as user interface, database, and loan management. Tools for creating UML diagrams. So to create UML diagrams, we will need the right tools. Popular options include Lucidchart, Microsoft Visio, and Draw.io. Lucidchart is great for cloud-based collaboration. Visio is ideal for enterprise level diagramming, and Draw.io is free open source tool that that's perfect for smaller teams or individual use. Choosing the right tool depends on our needs. Lucidchart is great for teams working collaboratively in the cloud. Microsoft Visio is the go-to tool for businesses that require detailed and professional diagrams. For individuals or small teams, Draw.io offers a free, accessible option with many features. In conclusion, UML diagrams are essential for high-level design in software development. They provide clear, standardized ways to represent the structure and behavior of a system, helping teams communicate effectively. Mastering these diagrams, especially class, sequence, and component diagrams, will enhance your ability to document and communicate system designs. Thank you for your attention. Now, I would like to open the floor for any questions that you have. Feel free to ask about UML diagrams, how they are used in high-level design, or any other related topics. Let's discuss.